Hello guys, welcome back to Data Threads. Hope you all are geared up for upcoming contents. Thank you for subscribing to the channel and welcome to the family. If you haven't yet seen our introduction video, please watch it. The link is in the description below. So yes, let's begin with our learning now. Today we are going to see what is the relation between artificial intelligence, machine learning and deep learning. Then we will see what is machine learning. We will also see the workflow of machine learning. What are the types of machine learning algorithms, and some real world applications of machine learning. In the diagram, we can see that artificial intelligence is the superset, the umbrella under which machine learning resides. So, machine learning is the subset of AI, and deep learning is a subset of machine learning. So, what is AI? Artificial intelligence is a field of computer science dedicated to solving cognitive problems commonly associated with human intelligence, such as learning, problem solving, and pattern recognition. What is machine learning? Machine learning provides computers with the ability to learn without being explicitly programmed. In layman language, we can program a machine to learn from every attempts or experiences or data points and then improve the outcome. We will go through the technical definition later. Deep learning. Deep learning is a subset of machine learning where artificial neural networks, algorithms inspired by human brain, learn from large amounts of data. Okay, that was a general overview. Hope you are good to go ahead. For any queries, comment down below. Let us deep dive in machine learning now. This is Joey. So Joey is constantly hearing the buzzword machine learning from his friends and also on social media. He is curious about machine learning and feels that he should also learn this cutting edge technology. But where to begin? What actually is machine learning? In the previous section we saw general definition of machine learning. Now let us go through a technical definition of machine learning from Tom Mitchell. Tom Mitchell is an American computer scientist. He has written books on ML like Machine Learning, A Guide to Current Research, and Machine Learning and Artificial Intelligence Approach. The link is mentioned in the description below. So according to Tom Mitchell, a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T as measured by P improves with experience E. Now let's understand about the data. The input data can be categorized into three types: structured data, unstructured data, semi-structured data. So what is structured data? Structured data is a data that has been organized into a formatted repository. Example, database. Unstructured data. Unstructured data does not include a predefined data model. It is usually created by MP3 files or JPEG files. Semi-structured data. Semi-structured data is a form of structured data that does not conform with the normal structure of data models of databases, but yet contain tags or markers to separate them. Now we will go through with the workflow of machine learning. Raw input. Here the input data can be structured, semi-structured or unstructured as discussed previously. Pre-processing the data. Now the input data is pre-processed using various statistical and mathematical operations. This includes filling missing values with central tendencies like mean, median, or mode, outlier detection, label encoding, scaling, normalization, and many other techniques. We will discuss these steps in details in our future videos. Exploratory data analysis EDA. After pre-processing, we do data exploration using various visualization methods like plotting various graphs using Matplotlib, Plotly, Seaborn, and Pandas profiling, and get the understanding of data and its distribution. Feature extraction. In feature extraction phase, the most important features, that is columns in the structured data and pixels or edges in image type of data, are taken into consideration for prediction. The techniques here used are PCA, Principal Component Analysis, Pearson correlation, and many more. ML algorithms and model selection. Once the features are extracted, depending on the problem statement, various machine learning algorithms are used, and the best ones with generalized data are selected. Prediction. Now comes the final phase of the workflow. Prediction is done on the unseen data. We see if our chosen model performs well in accordance with the problem statement. If we are not satisfied with the prediction, then we again try with different models or by parameter tuning. Don't worry if you don't understand, we will explain in detail each step in upcoming videos. Now let's discuss about different types of machine learning. Supervised learning. In supervised learning, all data is labeled and algorithm learn to predict the output from input data. Supervised learning is bifurcated into two types: regression and classification. Unsupervised learning. Here, all the data is unlabeled and algorithms learn to inherit structure from the input data. It has two types: clustering and association rules. Semi-supervised learning. In this, some data is labeled, but most of it is unlabeled and a mixture of supervised and unsupervised techniques can be used. Okay, so we went through a lot of theoretical concepts now. Let's move into some real-world applications of machine learning and deep learning. Let us look into the first application, the self-driving cars. It is capable of sensing its environment and moving safely with little or no human input. We can see the example of a Tesla car. Let's go to the second application, object detection. It is a technology related to computer vision and image processing that deals with detecting instances of semantic objects of a certain class, such as humans, buildings, cars, and various objects. We can see in the example below. Let's move on to the third application. How AI can help in healthcare. What distinguishes AI technology from traditional technology in healthcare is the ability to gain information, process it, and give a well-defined output to end user for detecting diseases like cancer, tumors. The recent example is COVID and creating new drugs for curing patients.
Hey bro, so machine learning is not that difficult and fun to learn.
Yeah, it is indeed a voluminous and futuristic field.
So what did you find more catchy?
I was fascinated by knowing how AML can be used in healthcare. How about you?
It's great to see. I love the Tesla self-driving car.
Now how about we build application of ours?
Yes sure, but what?
Maybe, like this.
Haha.
Yes, now that we have basic understanding of machine learning, we can deep dive it in further.